we've hit our start time of 4:30. My name is Charlie Verboon. I'm the manager of collaboration services at Berkeley Labs. And my thought today was to talk a little bit about some of the trends that we see in real world at Berkeley Labs, discuss the impact of those, some of the key trends, hypothesize, maybe discuss some of the impacts we see on students who are entering the field, and provide a few recommendations. First of all, Berkeley Labs, for those of you who do not know, is a multidisciplinary national research lab funded by the Department of Energy. It's government-owned, contractor-operated. Our particular contractor is the University of California. Others are managed by the universities and private companies. 4,300 people, plus about 2,000 people will wander through the lab on any given year using any one of our 6 user facilities. So we see a lot of people from around the world coming with every different piece of computing equipment you can imagine. We do have a few famous people. We've had 11 folks that have won the Nobel Prize, and our 12th is Saul Perlmutter, who just won his and was in Stockholm on December 10th. So we now have 12 that have worked at the lab. The 4 trends that I'm going to talk about today are in the area of software, virtualization, hosting services, and workstation support. I've worked in some of these areas. The opinions that I'm going to be providing were gathered from other folks at the lab in a discussion group that I had. I would also like to caution you, these are Berkeley Lab observations. I'm not trying to tell you that the rest of the world behaves like us. I just want to give you one data point. So first of all, software, both as a SaaS service or on-premise, we've got a number of things going to give you some examples of what we're up to. In my particular area in collaboration services, we have moved from on-premise, locally managed mail encountering services to Google. We started that about a year or so ago. In fact, last July, we finished our calendar migration. So Mail Encounter, which Oracle Calendar and used to be some messaging service, are now Google. This brought along the idea, I wonder if they're being tossed out of the room here. We also have document sharing with Google Docs and websites like Google Sites that are available to our customers. In the HR area, those of you who live in the area probably have gone through San Ramon, Pleasanton area. Taleo is a company that does HR recruitment software. We're using them now instead of internally developed software. For the service desk, we're using ServiceNow rather than what we used to use was an on-premise Remedy installation. So even our help desk ticketing system is now cloud-based. And just to give you an example of something that we use every day, backups for desktops and laptops, we've outsourced to Carbonite. You've probably seen their ads on TV as a consumer service. We've got a corporate agreement with them. We're not in the laptop and desktop backup business anymore either. Some of the on-premise software we don't write, but we still implement. There's just a variety of things that you can do. We do a lot of technology transfer at the lab. So there's the software from Wellspring that we're starting to look at. The more important one, the more interesting one is in the area of environmental health and safety. I've been at the lab almost 12 years. We have got dozens of specialized apps that deal with environmental health and safety, from training to sort of certification that you've been through certain requirements at the lab. I think their goal is to remove all of them and to replace it with Simulate, at least for the components that they no longer have to do and maintain on their own. We use our traditional ERP system, financial and HR's PeopleSoft, project management, Primavera, and Microsoft Project, and in the future some other things. And in the backups for the server environment, we don't have a cloud solution, but we have UC Berkeley, which scales better than we do. So we're taking advantage of them and their Tivoli system to do server backup. So one message here is that where the IT division at Berkeley Lab probably should be named ICT division after this conference. But the IT division, one of their fundamental jobs was backups for servers, desktops, and laptops, and we're getting out of the business. So I want to talk a little bit about email. That was one of the services that we've outsourced to Google. In a typical month, we get about 13.8 million incoming messages, just like a lot of institutions do. But 85% of those things are stopped by what we call reputation filters, so they don't even start to get into our system for spam and antivirus control. We have about 3.5 million outgoing messages every year. Earthquake?
There's a red fire alarm. It's probably a call.
Well, so we were on our mail example, and we were talking about the volume of mail. This is a daily amount of mail that we would get, 500, 600,000 incoming messages a day. To support that environment, let's go back 5 years. This is a diagram of the equipment that we had in our infrastructure group that supported just production, not test and development. It has a few boxes that don't involve mail encountering, but it gives you a big picture of things that we are likely not to have to do in the future if we outsource to the cloud. These are sysadmin jobs, they're racking server jobs, they're buying hardware types of jobs. And a good chunk of this thing is heading south, going away. For us, personally, these are real numbers. About 1.3 million is what we're going to save in 5 years by doing just the Gmail portion and the countering portion. We still maintain gateways and anti-spam ARM port devices locally, so delivery and that kind of stuff is still done at the lab. Once we move that out, it'll be $2 million a year. We spend probably $500,000 over the, or excuse me, $500,000 or so over a 5-year period on locally provisioned collaboration tools that will allow, for example, web sharing of files with our researchers. That will go away as well. We have an expensive storage area network that we've moved out of the lab, and servers, monitoring devices, things like that are no longer going to be needed because of this move to the cloud. The software implications are of not just mail, but the bigger picture for us. There's definitely a reduction in the number of software development jobs, the Java coders, the .NET coders. Some of those guys were developing these one-off apps at the lab. But there is an increase in integration efforts. So customization, maybe special Java files or Java apps that have to supplement what the vendor provides. A lot of configuration with XML to be able to manipulate the thing the way we want it. And then actually a thing that you wouldn't think about, something called federated identity management. We do not want to provision user IDs and passwords on all of these different vendor systems. Number one, a user has to maintain n number of passwords, and it's in their area, not ours. So federated identity management means you point a browser to Google, and it says, oh, you're from Berkeley Labs. We'll deflect that to our identity management system. We will authenticate you locally at the lab, and then the lab says, this guy is really C.E. Verboom, and he's good to go. It does never do the authentication on Google's site. They don't have to really require passwords and those kinds of things in a true federated identity management system. So for Taleo, for ServiceNow, for all these, they're not holding user accounts for us. We do our own authentication. There's an increased emphasis on vendor interface. So one of my jobs is dealing with Google, and that's a frequent type of activity. Project management, when you're rolling out cloud services, is a big deal, and business processes sometimes have to change. You use someone else's software, they don't exactly do what you used to do yourself. So you have to change. There's definitely, for cloud-sourced apps, a reduction in data center, sysadmin, hardware acquisition, and installation types of jobs. Virtualization, another area of focus at the lab. Servers and desktops. Desktops not so much, servers quite a bit. Busy slide, but I want to give you an idea. This is one of 4 of our virtualization environments. It's using VMware. We have 4 Dell servers. There are 2 6-core CPUs each. So like the fellow from VMware noted, we look at that as a big aggregate of computing power. It's basically 48 cores, 256 gigabytes. That's what this thing presents to us. We run ESX4. Now, our idea is that you can run 8 virtual CPUs for every one of these cores. So that means that we have a maximum capacity of 384 virtual CPUs. If you talk to VMware, they'll say, well, you can do 25 for every real physical core, but we say it's 8. And what that tells us then is that we have some capacity for running virtual machines on this thing that we acquired. A virtual machine for us is typically spec'd at 1 to 4 virtual CPUs, many of them just 1 virtual CPU, which is 1/8 of a core. And they may run anywhere from 1 to 4 gigabytes. Things like operating systems are not stored individually within the VM, as we mentioned. They're stored one place and shared. It allows load balancing, so if one server dies, we have several, it falls over so that we don't have a discontinuance of service. Our standard VMs, as I mentioned, are 1 to 4 CPUs. We run Windows 2003 Server. We're moving to Windows 2008 now, and we have a Linux distribution. We use CentOS, which is sort of a Red Hat knockoff that the open source guys did. And so we sort of standardize on what virtual machine operating systems we will run. On this particular environment, we have around 100 virtual machines. 48 of them are production VMs. So things like Windows print servers, a Sophos antivirus server that sends out definitions, 1 vCPU each. The Windows Systems Update Service through Windows Patch Service. We get the patches from Microsoft and we roll them out to the lab from our server. That's virtualized. In the Linux area, we have a single VM that has 11 different PHP MySQL applications running on that one VM. Things that allow us to distribute software to our users, provide a little store if you need to get parts for some of our user facilities. It's sort of like going to eBay. We use Plesk. Those of you not familiar with that name, that's a commercial web hosting service that you might go to some vendor site and you want a virtual machine. They may be using Plesk. So we acquired the software. We run it on a virtual machine within our environment for internal. And we run collaboration systems. Those of you who are Blackboard oriented, you may be familiar with the term Zythos. That's a product, a company that was bought by Blackboard. It's web collaboration software, and we have 4 Windows VMs for that. So here's an example where you may be able to realize some savings. This is a building code management system that we're rolling out at the lab now. The vendor said you will need 3 servers. And there'll be a web front-end server, and an app server, a database server, and we priced it all out about $46,000 to acquire the hardware, which we assume will last 5 years. But we put it on the virtual machine environment. We have 1 VM for each of those 3, what would have been physical servers. 1 vCPU each, 4 gigabytes. The total cost estimate, based on how we priced this out, was $1,920 for 5 years. We obviously would never have used the machines that they had spec'd out for us to their full capacity. We didn't need that much horsepower. We need a lot less. So we're using virtual machines and at a significantly smaller cost than we would normally have had to have done. So interesting, if you're not used to looking at VMs, the load is actually surprisingly low. I was very, very suspicious of being able to take something a vendor said should run on physical hardware and run into a VM and get good performance, but it actually turns out not to be true. It works fine. Here's an example. This is a Linux virtual machine The vertical scale is percent of CPU. The highest spike is less than 17% of the CPU. This is a virtual CPU, 1/8 of a core. And of course, has different variations as the days go through the month. This is a wiki that we use. It's a commercial wiki from Atlassian Corporation. It's called Confluence. This has some of our division websites on it, forums, all kinds of projects that are run on this system. And it's a virtual machine. It never tags more than 55% of the CPU. And it has its ups and downs as you go through the day. But still, a virtual CPU, not physical. And this is another look at the usage of it. We have 400,000 page hits over a period of a few days. It might be search engines, even an internal search engine we run will really tag this thing. But it's not having any performance issues at all. This is real-time statistics for a particular day, the 12th or the 13th of December. And you can see CPU on the left-hand graph. It goes 70% on that particular day, one moment in time, but mostly very little. Memory never gets above 3.5 gigs. It does less at other times. This is a Windows print server, another typical use of virtual machines. The CPU percent never gets over 10% most of the time. There's a few spikes that go to 15 to 18% of a virtual CPU, which is 1/8 of a core. This is another look at a particular day, the 13th of December, and it's the CPU and memory. Memory is 150 megabytes. You can't buy a server with 150 megabytes anymore. But that's the load it takes. We have 4 of these print servers. This particular one services 150 printers used by folks around the lab. So that's the server thing. We have 4 different environments that are VMware-based that virtualize our server, and we're continuing to increase its usage, reducing physical servers. In the desktop world, we don't have much of a good story to tell. We do have a small training room. It's got 16 workstations. We've got something I didn't put in, but they're Planlogic devices, if I pronounce the word right, small little cube hardware boxes that don't have much in them. And we use those to get at VMware virtual machines for the classes that we run. And we can see other uses, our badge office, our guard gate, temporary workers that come to the lab that have sort of standard requirements might be a particularly good use. Other labs like Sandia and Los Alamos have heavily invested in this, and they have lots and lots of people using virtual desktops. So that's something we have to learn how to do more of because it's a high-cost item for us. Hosting services, internal. I mentioned Plesk. What would happen if you wanted to provide your own hosting service to people at the lab? So we bought Plesk. This is for the use case where people want WordPress or Drupal or any of these open source products. They might have bought a small server. They might have downloaded the open source software, and they might be running it for departmental uses. So Plesk can do that. It sort of has a cafeteria menu of products that it will install for you if you want to use it. I'm actually wondering about this now because 5 years ago, this was a big deal at the lab. A lot of people were out there grabbing that open source software, setting up their own systems. I'm now wondering about that. Maybe things like Office 365 and Google Docs and Sites are going to take away the need for some of that local do-it-yourself approach. So I'm not sure how much that's going to grow. And then we do allow customers at the lab to use virtual machines themselves as an energy-saving trade-off. Don't go buy your hardware. Don't use the electricity. Don't worry about air conditioning. Check out a VM from our area. We've also put some stuff on Amazon. So we have some systems that need to scale. They have really high usage sometimes and low at others. Environmental Energy Division has some stuff out there. We've actually looked at high-performance computing, which typically might have 500 nodes, and the job is done in pieces on each of those nodes. We're wondering how you can do that in the Amazon cloud, and we've experimented with that as well. So far, nothing production. Workstations. These are some interesting statistics, again, a Berkeley Lab Perspective. On the left-hand cluster of bars, you'll see our current inventory as of a month ago. 60% of them were desktops. That's the blue bar on the left. The red bar is laptops, and the little green thing is tablets. Really a 2-year-old phenomenon only. 60% desktops, 40% roughly laptops. The percentage of systems that were bought in FY10, that's the middle cluster, only 50% were desktops, and a bigger percentage were laptops. And you can see that trend continues last year. Fewer desktops, the blue bar continues to go down, the red bar continues to go up, more laptops, and tablets are starting to increase. So we're going to see that, I'm sure, again next year, where there'll be more mobile devices and fewer desktops that we buy over time. This next graph is actually a little too hard to explain, but one thing I want to point out is that we're a big user of Apple equipment, like a lot of other companies are. You can't be just Windows or whatever. A lot of our researchers and students come in with Apple, and it's great stuff. The top cluster of bars, the percent of total purchases, you know, iPads are the tablet of choice. They certainly were. So over 80% of our inventory or purchases last year were iPads. The red is laptops, so somewhere around 45% or so of all the laptops bought at the lab were Apple laptops, and the blue is desktops. So in the very bottom graph there is the percentage of total inventory. So again, Apple dominates the tablet market. I would say it pretty well dominates the laptop market. It's going to get bigger, I think, and desktops will be a factor. Here's what convinced me Apple was changing as a corporation. When our entire Unix group several years ago switched to Mac laptops. Now that's something that tells you that, well, it tells you a couple things. No, you know, they're not running Ubuntu on their laptops. They're not using Linux desktops. They're using the Apple operating system, which is based on BSD Unix. So they can do everything they want to in Unix and have a nice little interface. So when those guys decided to go Unix, or go Mac, I knew that we were into something, a real fundamental change here. There's another look at things from a Unix perspective. We run our own little business at the lab in the IT division. We support other people's systems in departmental computing in various research divisions. The the bars there represent the number of service contracts our group had. If you look at 2006, 230 or so individual systems were managed by our internal Unix group. That's down to 100 or so this year. That many different systems. The reduction in the workload for us is for a couple of reasons. One, desktop Linux is becoming easier for people to do on their own. They don't need a Solaris specialist anymore like they did a few years ago. It's being driven down to the user. The IT specialist, which that was his bag of tricks a few years ago, is not needed now. Also, some of the things that people were doing with those Linux systems, as I mentioned, are sort of going with our cloud offerings. They're being able to do the things they need another way. So as a result, the number of people who are doing server and desktop Unix Linux support at the lab for our customers is decreasing. So implications. There's a greater demand for multi-platform expertise. From our perspective, we cannot be a Windows shop or a Mac shop or a Linux shop. We really have to know a little bit about all of it. Definitely Macs are taking the Linux desktop market, we think. Linux systems are becoming easier to set up and manage, less support. Mobile devices are growing in importance. I'll show you why in a second. And I think, you know, computers are heading like the TV and radios. You have breaks, you repair it. You don't repair it anymore. It's too expensive for labor. So I'm wondering when we're going to get to that point. The mobile implications that are being driven are digital literacy is increasing, and of course the devices themselves are pervasive. Everyone who comes to the lab is familiar with this stuff and uses it as a consumer. So what that does is it causes the business systems to have to support that. They want to be able to get to their financial data, their calendar data, other things with their mobile device, just like they do their consumer world. And this requires that we internally, our help desk, for example, has to be more familiar with different devices and different operating systems, sometimes multiple implementations of the same OS. If you get a smartphone and it's Android and it's from two different manufacturers, the GUI is different. It looks different. Might have a keyboard, may not. So you have to worry about that. So one of our drivers is what institutional systems do we support that were traditionally desktop-oriented that now have to be available on tablets and phones. Our help desk. This is a really interesting use case here. So we have 4 people. For a desktop, each of them has got a desktop Mac, a Mac Pro, OS 10.6. We needed to get them into the Mac world. We couldn't give them another machine, which is a Mac, because they'd never use it. We gave them the Mac. And on that Mac, we put virtual machines using Fusion and Parallels in some cases. It might have Windows XP, Windows 7, a version of Linux. It might have various things that they have to deal with, but it's running on a Mac. So it's forced them to get into that. We also have some other systems, Dell Optiplexes and things that are common at the lab, so they have some hands-on. For laptops, we have a Latitude and a Mac Air, AirBook, and then we have tablets, iPads, and now Samsung Galaxies, smartphones, Androids, and iPhones. So our help desk world 10 years ago didn't need any of that. Needed a Windows desktop to be able to service our customers pretty much. Now they have to get familiar with a lot of different systems and mobile devices. This is from our networking group. Our number of access points for wireless at the labs going up radically. They want to make wireless ubiquitous at the lab. We have 70 buildings, so they have to put wireless points in a lot of different floors, a lot of different buildings, but people want wireless now. They don't want to have to hook into the wall. The speeds are going up. We're experimenting with 100 gigabit networks now. And it's the new research. Our gateways are 10 gigs out to the world, and 1 gig to the desk. We have a lot of cybersecurity issues that have to deal with it. If you've got that much traffic running on your LAN, you usually have intrusion detection systems that have to take a look at the packets to be able to find out what's happening. They have to be able to keep up with the speed of these networks as well, so there's big upgrades in that area. I think I'll slow this slide and move on. A couple of just comments. This is just an example. The number of DHCP leases, which is a good way of measuring how many people are walking into a room and trying to get a wireless connection, has gone up 3 times over the last 3 years at the lab. Again, proving that people are really looking at different devices and not the desktop anymore. Some recommendations for students, and this is one of my real issues, is what do we do for students coming out of community colleges when you see trends like this? Well, number one, there's a significant shift to commodity services. Basic observation here. Desktop Linux, we think, at least in our world, peaked. Mac laptops gained the market share. Mobile computing is key. Virtualization really works, and it's going to continue to grow in importance. So, from a technology point of view, you got to teach your students virtualization. So I know that the VMware folks have a program in Ohlone. It's the only college I know, community college, that actually teaches VMware. But it's actually pretty important. Zen's another example, and so, of course, it's Hyper-V from Microsoft. Parallels, Fusion, or Oracle VirtualBox, all things that you can get into, but students cannot come out without having a fundamental understanding of this. It's really important. System administration, again, the student has to be sort of multi-platform in our world. They have to learn multiple OSs, and they have to know a little bit about integration, how to make this stuff work. How do you take a Mac and give them access to your Active Directory environment, which provides file and print services? We have more Macs than we ever did. We have to give them file access to central file systems, so we have to deal with that problem, and of course we have to become proficient with those mobile devices. Networking, this is one of the things that I find really interesting. It doesn't seem to matter what area of IT you're interested in. Networking is fundamental. It is the single area we see people not understanding coming out of community colleges. They may have taken a class, they don't understand this stuff. So, and I think that's really a problem. They have to be somewhat oriented towards networking, even though networking is not their job title or intended to be in the future. Background electronics is helpful if you do want to get into networking, and of course wireless, as I mentioned. I think everyone needs a scripting language. It doesn't matter what kind of job you're in anymore, you can automate it. System administrators who do not know some kind of scripting language cannot do their jobs effectively. So in some way, you need to give them Perl, Python, PowerShell. Pick a scripting language. They don't have to be C++ and Java guys, but they should be scripting guys. And they should definitely be familiar with XML, because a lot of the configuration of these software products is basically XML. Security. A lot of schools are starting to get security programs in community colleges. I think City College in San Francisco is a good example. Our problem is that we don't see security as an entry-level job. You can't take a kid who's been in this 1 or 2 semester class or even a year and put them into a security group. Security at the lab requires a broad understanding of many technologies and a deep understanding of at least one. So an example for us, we have 4 people in our cyber group. To come into that group, you better demonstrate expert knowledge of either Windows or Unix or something, and then have broad understanding of networking and other things. You've got to come armed for the battle with a lot of experience in one area. So I'm not 100% sure where the security-related folks are getting that initial job in industry. They're certainly not going to get it into usually a small, very highly technical group in the security cyber area, but it may be in some other area. My general recommendations for education are focus on how you learn versus what you learn. How many of you remember my day and age, Data General, Wayne, DEC, Prime, companies that dominated the mini-computer market, and they're no longer here. So if that's how, and Novell. This caused one of our folks at the lab tremendous angst. He was a Novell system admin, and he was very good. And the job went away, and he couldn't believe it. He couldn't buy into that. So it doesn't work at the lab anymore because we don't use Novell. A really good indication, as I thought I tried to tell him, was that if the community colleges don't teach it, then for sure it's not something that's going to be used in industry anymore. And you remember back in 95? Well, in 95, and everyone wanted to go to their community college and get a Novell cert. That was a job, type of thing. But it's not being taught there now, so that should give you a hint. One of the folks said, learn technologies that help companies move forward. Come to us with something like virtualization knowledge. Maybe you did get a chance. You were lucky enough to get a VMware class, and you got through that class. Maybe you're certified, maybe you're not. But you come armed with something that we need because we're trying to move in that direction. So that's a good hint. Critical skills. Hands-on, you can't beat it. Los Positas has an interesting program where they have an internal help desk, internal desktop support. You get a student that's been through that little experience at that community college, and they're a great intern for us. Do they work for a nonprofit? Do they fix their friends' computers? So those things are really important. I really think that a student who thinks that they can get out by memorizing answers to tests, and that's all they are good at. They can memorize answers to tests, but they've never physically done anything with it or doing themselves a disservice. It's amazing how well qualified they think they are. They come to an interview and they have no understanding. People come with an A+ cert and don't really know hardware. Pretty sad. But we do think very strongly of getting those extra communication skills, verbal and written. Let's see, how am I doing? A couple more minutes. So I think from a job hunting point of view, I think it's been mentioned today, go find the job you want at the place that's likely to have it. So maybe sysadmin is your thing, but probably Berkeley Labs not going to be hiring a lot. Now, we've got 2 people who deal with our virtualization centers that would do traditional sysadmin. Go to Amazon and Rackspace. Maybe those are the folks that need to hire you. Or go to a software vendor like Taleo or Google if you want to develop the programs. Go to a vendor that's doing desktop support and printer support for other companies. I know HP does that kind of thing because a lot of companies are getting out of that business themselves. And come to organizations like Berkeley Labs if you want to integrate and implement stuff. So if you're going to implement Taleo, you better know a little bit about HR. You better know a little bit about the authentication mechanisms that we're going to try to put in place. You're going to deal with projects, dealing with people. You're going to do things more like that than writing code. And my final slide is this. I don't know where the entry-level jobs really are anymore. I'm trying to make a guess. I know that the help desk, at least at the lab, is. By the way, we've had 64 interns in the last 12 years from community colleges in our local area in the IT division. We've hired 23 of them. So it's a good way to get your job. But what is that first job? For us, it's still help desk. Desktop field support is the next biggest. But I'm worried about that because I don't know how long we're going to do a lot of that. So we have to go to a different company perhaps for that intern. Software tester. Folks who are taking programming classes wind up not being able to get jobs right away, but look for an internship in testing software that can lead you into something else. Cable installer, electrical technician, maybe that gets you into the network area. Technical documentation, maybe that gets you into business process analyst type of work. But what I think you need to help us with is what are the entry-level jobs? What is the progression? What do we tell our students, to aim for when they come out of a community college? And I'm talking about folks not who have a lot of experience and are taking that one extra class. I'm talking about the person that's looking for their first job. So basically, that's a homework assignment. I'm really worried about the next set of interns for the next decade. We need to find places for them to look.
We don't have a lot in our area, but the